Hey i211. So, in this unit where we're talking about Python programming in a Unix-like environment, we've talked a little bit about text editing with Visual Studio Code. We've talked a little bit about the process model with Unix, starting and stopping programs, waiting for them to complete. We've talked a tiny bit about testing, just so that we can get comfortable with this idea of validating whether our programs meet certain expectations. And now we want to put all of these pieces together with these things that we've talked about: Unix, files, folders, using Git and GitHub in order to make commits and keep track of our changes over time. And we want to test all of these things inside of this example of building a increasingly complex rock, paper, scissors game over the next couple weeks. So what do we want to accomplish by the end of this lesson is that we want to create a program called rps.py. And when we start this program with Python 3, we're going to get some input from the user. So notice that it's prompting the user to either choose rock or paper or scissors, which is maybe reminding you that there was this thing called the input function in Python. Well, the user can type anything they want in here. So we also have to do a little bit of validation. So let's say the user tries to input the word cannon. Well, cannon is not a valid choice within rock, paper, scissors, so we should give the user some feedback saying that cannon is an unknown option and that they should try again. So we probably need some kind of way in order to loop or do some validation over that. Put that on the back burner. However, if everything goes okay, such as that the user chooses scissors, then we are going to additionally make a computer choice. So probably some kind of random process that chooses either rock or paper or scissors by the computer. And in that case, we will evaluate whether scissors beats paper and conclude that either the human was the winner or the computer was the winner. So there's two components to this. One is the actual implementation itself, and then there is the other point, which is about this workflow that we've been practicing over the last couple of days. So the first step is that we're going to set up our work area using Git and GitHub. We're going to figure out how are we going to start with some of these functions and implement them iteratively to the point where we arrive at a final solution. We'll need to do a little bit of planning about what subset of Python are we going to need, and we're going to need to get some practice running these tests and checking whether our code is meeting expectations. The other point that I think is really important within this whole workflow, which we'll use step 6 as an example of this. Notice that we have a function such as this get computer choice, and we can evaluate whether or not it's meeting it's outputting something that we expect it to. Well, we can evaluate whether it's meeting our expectations by running our tests that were written ahead of time against it. So if we can run Python 3 and run the tests for RPS and the specific subsets of tests that are testing this whole thing about getting the computer choice, in the event that we can run all the tests and get good feedback that all of these tests are meeting the expectations, that's a good point that we would want to make a commit. So we should be frequently saving our code and running it in order to see whether it's meeting our expectations manually. But once we get to a point where our code is meeting the expectations and is passing the tests, that is a really good point that we should be making a commit that we could potentially return to later or get back to if something goes catastrophically wrong, which, side note, sometimes things do go catastrophically wrong within software development, and it's really useful to be able to return to one of the previous commits when you did have working code. So a couple of things that I want you to take away from this, from this little practice session. One is that making a lot of small functions are usually a lot easier to evaluate and reason about than some giant blob of code that may be doing a bunch of complex things all at once. The other point is to focus on the workflow. So the workflow of running your code on your personal computer, making a commit when you have things in a working order, pushing up to GitHub, and doing all of those other steps that we've talked about over the last couple weeks. So I don't have much open at the moment, so I'm going to kind of start from square one. So step 1, how do we set up our work area? Okay, well, I need a terminal in order to accomplish this, so let me open a terminal. Okay, we got a terminal. I'm in Windows, so I have my Ubuntu opened up. And I also want to open up our GitHub organization, where notice that I want to find my repository for the i211 starter. So let me go ahead and click that. Notice that I don't have any commits out here just yet. So let me just get started. So how do we get started again? We have some instructions, but I will kind of do this the manual way to show you like what this would look like. So let's see, where am I? I'm working on i211 stuff, so I would like to be inside of my i211 directory, where I was previously working on the scratch space repository. And I want to clone this repository to my local machine. So I selected the URL. I'm going to go back in here, right-click to paste. Control-Shift-V would also work. I'm going to change this very slightly just because my machine is configured in a very slightly different way. You probably don't have to do this. Okay, so we clone the repository. If we do an ls, then we see that we now have a directory, so Hazel i211 starter, which should exactly match that thing out here on GitHub that we just cloned. So now I will cd inside of it, maybe do an ls just to inspect that I do indeed have 1, 2, 3 files. 1, 2, 3 files matching this. Notice that these begin with dots, so those will be invisible by default, but I can obviously show them if I do the ls-a to show all files and folders, even the hidden ones. Last step. Okay, so give myself a little check mark. I cloned the repository. I changed directory into it. Very last step, code space period or code space dot will open the current directory in Visual Studio Code. At this point, I don't really need this terminal anymore, so I'm going to go ahead. A little bit of something went off right there. I'll check that later. Okay, so I could continue working out of this terminal right here, but the nice thing about Visual Studio Code is that it does have its own terminal built in. So if I do Control-J or Command-J on macOS, I think is the keyboard shortcut. And notice that that's just going to open up an integrated terminal that still has access to all my files and folders. I can still run git status inside of here, but it's just a little bit more convenient than just tabbing back and forth between these two in order to just run whatever commands I need. But all terminals kind of point to all terminals point to the same place on your computer, so whichever workflow you prefer is really okay. So let me take a couple of seconds, kind of get situated. I have an rps.py inside of here, which has all of those 1, 2, 3, 4, 5, 6 functions I expected to. We also have this test RPS right here. Okay, maybe we'll get into that whole test RPS thing in just a moment. So what do I want to do first inside of this? So check mark. I set up my work area. Next step. I did read the starter file in VS Code. Yep, I opened VS Code. It did contain the 6 function signatures described later. Read the names of each function and their signatures. What might the inputs and outputs of each look like, and which functions might take similar arguments? Okay, so what this is pointing us to is that the names of these functions are probably going to give us a really good hint as to what they should accomplish. So getting a computer choice, that's probably going to involve this whole random.choice thing in order to figure out like what choice would the computer make. Easiest way to implement artificial intelligence in this case is just to choose something at random in this situation. Standardizing RPS choice. Okay, so standardizing. This has probably something to do with the fact that the user could input something like rock, but rock, all lowercase, might be a little bit easier for us to reason about. So standardizing is typically something where we take a raw input and convert it to a standard input. So take a raw, all caps rock, and then convert it to a standard format that we decide on. Getting human choice, kind of the same idea. This will probably involve that input function, beats. Ooh, beats. Okay, so then we're going to have a function down here that involves the idea that the human can make a choice, such as, I think scissors was the example in the directions earlier. And the computer can also make a choice. So notice the parameters, so if the human chooses scissors and the computer chooses paper, then we want to output some kind of Boolean for whether the human beats the computer. So in this instance, we would say that yes, the human did beat the computer, so we would return true maybe in this instance. Deciding winner, notice that this is actually super similar. So we take a human choice and we take a computer choice, and maybe this would do something like, let's see, winner is the human. So maybe we would return something like that. Main doesn't return anything, but notice that that's simply going to be called whenever we run this code. So I bet right now what we're going to see is that nothing's going to happen when we actually do Python 3 rps.py, which kind of makes perfect sense because down here inside of our main function, there simply wasn't anything. But if I were to add something in, like, welcome, I am inside the main function, exclamation point, give it a Control S to save, up arrow to rerun run the last command, enter to actually do this. Sure enough, now that we actually have some print statements inside of this, well, welcome, I am inside the main function, which perfectly matches what we ran out here. Okay, so I think we have a rough idea of like what all of these functions look like. So let's give ourselves a little bit of a check mark next to this. We also talked a little bit about like what subset of Python do you think we're going to need? It's probably going to involve this random.choice. It's probably going to involve this input function inside of Python. And we're probably going to need, well, a series of print statements in order to give feedback to the users. Okay, so next up, let's run the tests and see what they look like. So since we are just getting started, we should expect to show that our work is not complete. If we run the test rps.py with Python 3, then we're probably going to get something that says that we ran a bunch of tests, but none of them passed. So let's go ahead and verify that. So instead of running rps.py, let's now run Python 3 test_rps.py, enter. And sure enough, okay, so we ran 27 tests and quite a few of them failed. Okay, so we are not done yet. So it is okay that our tests are not passing just yet. Let's give ourselves a check mark. Oops, pardon me, sorry about that. Give ourselves a check mark. We have run the tests and shown how they work. Okay, so now let's get into how do we actually get the computer choice. Okay, so back over here, now we want to actually think about like how this function is going to work. So maybe we can look at these two things side by side. Okay, so the way that we want to do this get computer choice, if we just call this function as is, notice that it might return scissors or it might return paper. Okay, so every time we call this function, it's potentially going to return something different. In other words, okay, the getComputer function should behave randomly using the built-in choice from the random module in order to return either rock or paper or scissors. Okay, so while implementing, yeah, let's try it this way. So let's add a couple of calls underneath the function in rps.py so that we can get some feedback immediately as to what this does. Okay, so if I tried calling like getComputerChoice like this, and what if I do that maybe a couple times, so copy and paste it a couple times. What if I just return like scissors as a hard-coded argument? Well, if I just call scissors as a hard-coded argument, then we should expect these three print statements all to return just the string scissors and print them out. So if we do Python 3 rps.py, sure enough, scissors, scissors, scissors. That's probably not a very interesting random choice though. How might we use this choice function in order to do this? Okay, yeah, so what happens if we implement getComputerChoice and run rps.py? Well, okay, so we try to run these. It may not return what we quite expect. So let's actually see if this is meeting our expectations. Okay, I thought, oh no, okay, small technical difficulty. Technically what I want to run is this test right here. So if I do Python 3 test rps.py, Control-Shift-V, I want to run the tests specifically for getting computer choice. Okay, that's going to show me a bunch of information. It's only showing these scissors. And okay, what actually happened? Well, we tried to run the tests for getting a computer choice, but okay, assertion error. Items in the second set, but not in the first. Oh, okay. Well, here's a problem. We expected that this function would sometimes return paper or rock, but it never returned anything other than scissors. Okay, so that gives us some really good feedback that we need to somehow write this so that we can return one of these three options. So we need to do something like options equals either rock or paper or scissors. Okay, And then, once we have some options defined, we probably need to use this choice function in order to get a random choice. So maybe we'll call this the computer choice is equal to calling the choice function on our options, and then we will simply return the computer choice at the end. So now what happens when we run this code, given that we have implemented a solution which may get a random options from the set and return it at the end? I'm really hoping that now we will see something like paper followed by rock, maybe followed by paper again. Let's see if that's what happens. So Python 3 rps.py. Okay, maybe we were very lucky, we got 3 different options this time, but okay, if we run the code multiple times, we get slightly different results every time. Now let's see if this will actually run our code correctly when we do that test rps.py. So I'm skipping ahead a tiny bit. Yeah, actually get the computer choice this time. That's yeah, so we showed a couple ways to kind of debug this manually, and now when we actually run the code, we're probably going to get something much better. So now let's do that Python 3 get computer tests. Paste that in there. Oops. I'm going to do Control C because I kind of messed up. Control Shift V to paste that in there. So test rps.py, run the computer choices. There we go. Okay, so we ran 2 tests. Give ourselves a little check mark. We have working, functioning code. That means that we're probably ready to do a little bit of cleanup. So I will clean up these 2 functions. And let's see, so I clean these 2 up. I have a working solution. Let's run the tests one more time, confirm that these work. And then, what is that thing we do when we have working code? What is that thing we do when we have working code? We create a commit. Okay, so let's do git status to confirm that we have made modifications to rps.py, which notice Visual Studio Code is also going to show us modified, modified. That's actually what these little bars right here mean. So let's add rps.py to our staging area, confirm that it goes from red to green, and let's make a commit that says something along the lines of implement get computer choice. Perfect. Okay, 3 insertions, 1 deletion. We have one of these implemented. I'm not going to push just yet. Okay, so next step. How do we know what's valid? Okay, so this is that point we were discussing a moment ago. So users of our program could really write anything. Maybe they would write rock or rock or rock or even rock, and all of them could be valid choices. So we want to write a function, standardized RPS choice, that can take any variation like this, so rock or paper or scissors, and would standardize it into some common form. So notice rock would just return itself, paper would just return itself, scissors would just return itself. But if the user does a mix of uppercase and lowercase characters, we should turn them all into these standard forms as well. Okay, so if we have all capitals rock, we still want it to output just the all lowercase rock. Paper, all lowercase paper, scissors, all lowercase paper. Spaces and other invisible characters can also be a little bit problematic. So if we have a bunch of spaces before and after rock and before and after paper, we also want to standardize those into just the word rock or just the word paper. Okay, so hold on. How do we do this in Python? Okay, so a couple things. First thing, we're always going to output all lowercase information. So rock or paper or scissors, all lowercase. How do we convert? So how do we convert upper to lowercase? That's a question we should try to remember. And how do we remove spaces? So we could kind of puzzle through these. There are a couple ways that we could think about these. The really good shorthand way, if we remember from some of our intro Python stuff, is that in strings, we have access to methods like .lower, which converts from some representation into lowercase. And we also have access to some of these methods like .strip, which will remove these spaces from the beginning and from the end of the words. So how might we combine these ideas, like lowercasing the strings, stripping the spaces before and after, in order to standardize the RPS choice? Okay, well, same as before, I'm going to write myself a little bit of a manual check. So how would I standardize the RPS choice? Well, let's say we just print standardize RPS choice with, I don't know, all caps rock, maybe print standardize, try that again, print standardize RPS choice with lowercase rock, and maybe one more, but with the stuff at the beginning and the end. So let me add a couple spaces right here, and maybe a space at the end, and capitalize the K, because why not? Okay, so now if I run rps.py, okay, well, none, 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 which makes perfect sense because we're not returning anything from this function. If I just return the word raw, then we should just return exactly the word and therefore print it out. So now if I run it, we're probably going to see all caps rock, followed by that one with the weird spacing on it, which is exactly what happened. Okay, so we hinted that we might need something about like dot lower, we might need something about dot strip. So, okay, so how would we first convert things to lowercase? Okay, well maybe we could say lowercase is equal to raw dot, VS Code is kind of helpful to us, for us. It's giving us a lot of hints as to what this might be. Is there something like, yeah, lower is inside of here. Open close parenthesis to actually call this. Okay, so now we have successfully converted the words to lowercase. So now I bet if we rerun this code, okay, everything is lowercase, but we still have kind of this nuisance thing where we have the string, the spaces before and after the word. Okay, so we've converted it to lowercase, but we also need to strip it. So maybe let's also add another step called stripped, where we say is equal to lowercase dot strip. Okay, and we will now return stripped at the end, which I'm really hoping this will do something where we will just see the word rock 3 times. I think we got it. Okay, so we've iterated a couple times and arrived at a solution that looks like it's going to be correct. Let's remove a couple of these manual tests and see if our code is actually meeting the expectations inside of the standardized choice tests. Okay, moment of truth. Do we meet expectations? Control-Shift-V to paste. Ooh, interesting. Okay, that was the standardized RPS choice. I wonder if there was something that I missed inside of it. So we should take a RPS choice, so canon equals empty string. Standardized RPS choice. Okay, I'm going to do a little bit of live debugging here real quick. So, Oh, okay. So there's another idea inside of this. Maybe I'll add a note to the book for people watching in the future. Okay, so this is a great thing to catch right here. So canon is not a valid RPS choice. So maybe we also want to do something like testing that standardizing RPS choice when they include something that's not valid probably shouldn't be a valid choice. Ooh, okay, so this is actually kind of jumping ahead to some of the ideas that we want. So notice that nowhere inside of this so far have we said that only rock or paper or scissors is exactly what the human should choose. Okay, so there's one thing that the way we wrote the tests is actually catching for us, which is that we can standardize a choice, but what happens if the user chooses canon or, I don't know, bomb, or, I don't know, lizard right here? This would also be a good choice when we are standardizing to also check whether or not any of this stuff is a valid option to begin with. So we are standardizing by lowercasing and removing spaces before and after. Let's also check that it is valid and return the empty string if not. Okay, so this actually is way easier because if the user threw in like, I don't know, all caps rock or scissors, it would be really, really hard to check every possible variation that the user could do. But now that we've standardized it, it's really easy to say something like, if the strip choice, so stripped is in maybe rock or paper or scissors, then we will just return it stripped. Otherwise, else we will just return the empty string. I think this is a lot closer now. Okay, so let's do another little check for that thing that we were trying earlier. So we will standardize the RPS choice and do what was that example? Lizard. Yeah, so lizard is probably not a valid RPS choice. So we should now return and print the empty string when we run this code. So try that again, rps.py. Nothing got printed, which actually makes perfect sense because we just returned basically an empty string. Let's maybe make this a little bit more obvious. If I do rock, if I do scissors, there we go. So now what we should see is rock followed by nothing followed by scissors. Let's try it now. Sure enough, rock followed by empty followed by scissors, because this one is a valid choice, this one is a valid choice, but this thing in the middle is not. Okay, let's run the tests one more time and see if we actually pass. Okay, so RPS, standardize the RPS choices, Control-Shift-V to paste. 7 tests, all of them passed. Give ourselves a little check mark. Okay, so next step is let's do a tiny bit of cleanup. Let's make a commit and move on to the next step. Okay, so notice that Visual Studio Code is kind of muting out this, which is a sign that this code cannot be run. And that's because both branches of our if statement are exhaustive. We cannot have anything else other than these two things occurring. So this line is basically useless at this point. So let's take out a couple of these print statements. Let's maybe tidy up our code if there's anything. So maybe I'll fix my capitalization, check that the choice is valid, and return empty string, maybe otherwise. I like the word otherwise a little bit better in these cases. Anything else I can do? This one's a little bit silly, but I tend not to like else statements when this is just as good. So maybe I'll do that one more time if you haven't seen inlining an else statement. So we can't really have anything out here. So in those cases, I usually just prefer like removing the else block and just preferring that. A little bit of a stylistic thing, not really something you have to do if you don't prefer that. But let's run the test one more time. Everything is still good. This is a good time to do git status, git add rps.py, and say something along the lines of implement or maybe add standardize RPS choice. There we go. Git status, ahead by 2, working branch clean, nothing to commit. Okay, getting the human choice. Let's see if that's, oh, actually, recommendation is to skip ahead to the beats function. Okay, I think I'm kind of remembering why I wanted to do it this way. Okay, so this beats function should take a human and a computer argument and return a true or false according to whether the human choice beats the computer choice. Okay, and I'm actually going to pull these 2 examples right here. So below my beats function, I'm going to add some manual tests, checking that rock maybe beats rock, and rock beats scissors. Okay, so the idea behind this one, okay, so for example, rock does beat scissors, so we would say, treat this like does human beat computer. So in the instance where the human chooses rock and the computer chooses scissors, we would say true. The human does indeed beat the computer in this situation. But if both of them choose the same thing, does the human beat the computer? No, the human would not beat the computer in this instance. This would technically be a tie, but I don't think we're quite ready to think about ties just yet. Okay, so this one's kind of fun to think about. In fact, I think I posted like 4 or 5, like 4 different ways that you could think about this one. So let's see, which way do I want to go first? So the essential data inside of this is that we have something like a human choice and a computer choice. So maybe there's like 3 things that we could do. So like if the human is equal to rock, maybe we'll just start with this one. So if the human chooses rock and the computer chooses scissors, then that's a case where we would want to return true because the human would win in that case. And maybe we want to also check, well, okay, well, what if the human chooses scissors and the computer chooses paper? Okay, well, that's also a valid choice. Okay. okay, well, or what if the human chooses paper and the computer chooses rock? Well, yeah, that also works. Because because paper covers rock, scissors cuts paper, rock beats scissors. So, ooh, we've actually enumerated all the possible cases where the human can beat the computer. All of these other instances, such as where they choose the same thing, where the computer beats the human, is actually all false in this case. So we could just say otherwise return false. And I think this is a valid solution. Let's check our work to see whether or not this is kind of meeting what we think it should do. So rock does beat scissors, rock does not beat rock. So we said a second ago this should return true followed by false. Let's see if we run rps.py and get true then false printed out. Okay, so python3 rps.py, true and false. I think we might be onto something. Okay, we have some tests, so let's run all of the tests that we have for checking whether or not the human is going to beat the computer. I think we got it. Okay, so I think we have a working solution, or at least it appears that all of our tests are satisfied. But one thing I want to point out, I don't really like this solution actually. This is a valid one that you could definitely come up with, but I think there's a lot of simpler ways that we could do this. So if you want to, poke through a couple of these because there's a bunch of different ways that you can think about this. The one that I really prefer, notice that the essential information is that there's 3 possible cases and there is an ordering over the human and the computer. So we have something like rock followed by scissors, and this is going to be an instance that the human is going to be the winner. So what if instead we just create some kind of list containing all the situations where the human wins, and if it is not a member of that set, then we conclude that the human did not win. Let's put that into practice. So what are the instances where human wins? Well, the human is the winner, like we said, when rock and scissors. I'm going to be a little bit pedantic with my quotes here, just because I like the double quotes. We also said that it's a case when the scissors beats paper, and when paper wraps the rock. So these are all of the instances where the human is the winner. So we could also conclude that if the human followed by the computer, so if this tuple is a member of this group, so if the human followed by the computer is in the list of human wins, then we return true. Otherwise, we return false. Otherwise return false. Okay, we got rid of a lot of code down here. This is all muted out and we can't see. Let's see if this is an equivalent way. In other words, does this also pass the tests? It does. Okay, so I think we've actually simplified this code quite a bit. It's maybe, in my opinion, it's a little bit easier to read. Let's do a couple other things. So, okay, so if human computer is in the human wins, I kind of don't like having this variable that's only used once. So what if I just replace this human wins thing with the actual definition? Okay, well now we have if the human computer is in this list, then we're going to return true. Otherwise, we're going to return false. This is also an equivalent way to think about this. But wait, if we return true, otherwise return false. In other words, all we're evaluating is that return that the human and computer is in this list right here. We've simplified the solution, so now it's about 4 lines of code. Let's see if this is also a valid solution. Okay, so there's a couple things that I want to emphasize with this. One is that sometimes it's very easy to see like a simple, like a complex solution, and it's totally okay if you stick with the complex solution that you come up with the first time. But oftentimes, once we have that complex solution, it's a lot easier to rewrite it into a form that's a little bit easier for us to reason about. Personally, I think it's a little bit easier to just look at this and say, okay, well, if the human followed by the computer is in 1, 2, or 3, those are all of the cases where the human can beat the computer. So maybe I'll make a little doc string for myself that says like, does the human beat the computer? These are all of the cases. We have enumerated all the possible ones, and there's nothing else inside of this set that would be an instance where the human would be the computer. Okay, so with all that, I think that we have a successful implementation. So let's say something like git add. Nope. I'm going to be really precise with this. Try to follow and explain all my reasoning. So I will add rps.py to the staging area, show that it goes from red to green. Now that it is inside of that, let us make a commit that says implement beats function. Okay, git status. We have made a total of 3 additional commits so far. Okay, so give ourselves a check mark next to the previous step. Now we want to use this beats function to decide who the winner is. Okay, so now that we have beats implemented, let's use it to implement the decide winner function. Okay, and this is where we actually want to get into the idea of, is it a tie, is the computer the winner, or is the human the winner? Okay, so one of these cases I think is really easy. So if the two things, so if the human and the computer both choose the same thing, this will always be an instance where it's a tie. Deciding winner. So okay, so we have 2 of these. This one's pretty easy to check because we can just double check if those 2 things are equal to each other. This one right here is also pretty easy because we just wrote a beats function. Oh, okay, so we can use our definition of beats in order to decide the winner. Now what do we have left? Well, if it's not a tie and if it's not the human winner, the only thing that would remain is that the computer would be the winner. So I think we see how we might implement this. So if the 2 things are equal to each other, we say a tie. If the human beats the computer, then the human is the winner. In all other instances, we say that the computer is the winner. Okay, so let's pull a couple of these things. So I will copy these, go down to my decide winner, give myself a little bit of space, maybe print out decide winner with that, print out, I'm just going to copy this one as well. Print out the result of deciding winner with scissors and paper. Okay, so at the moment, these should print out none, none, none when I run rps.py because we haven't actually implemented anything just yet. So yep, none, none, none. So now we have to think through that thing that we just talked about. So we want to use the beats function inside the definition of deciding the winner. Okay, so let's see, the 2 cases we talked about is that we said it's a tie when these things are equal to each other. We said that the human is the winner when the human beats the computer, and otherwise, and it's a computer else. So 1, 2, 3 possible situations. That's giving us the hint that we probably need some kind of conditional logic inside of this. Okay, so I think the easiest one to start with will just be this tie case. So let's do something like, if the human is equal to the computer, we will just return the word tie. Okay, and I think we might have part of it already. Let's see if we can actually run the code and if this one meets our expectations. So I'm hoping we see something like tie followed by none, because these 2 are not covered, but this one is a tie. Let's see if that happens when we run rps.py. So Python 3 rps.py, and good. Okay, so in the instance where we have rock followed by rock, we do indeed get a tie. Okay, let's do the next one. So we've covered this case. We have this part solved. Now let's use our beats function and say otherwise, or elif, if the human beats the computer, we return that the human is the winner. Okay, we're building up a solution. Now let's see if this one returns tie and this one returns, oh, no, that's not right. This is a computer case. This one should return human. So we should see tie followed by human when we run rps.py. Yeah, tie, still none, and then the human. So that means this one is good. The only thing left is the instance where the computer is the winner. So otherwise, or else, return computer. And this is now muted. We know we don't really need this pass statement anymore. So finally, tie computer human. I'm feeling pretty confident in this. Let's clean up our code a little bit. and run the tests. So we have some tests called deciding winner. Let's do Python 3 test rps.py decide winner tests. Yeah, ran 9 tests. All of them are okay. Final cleanup. I don't need these print statements anymore. I said earlier, I kind of like inlining this if I can. So if the human is equal to computer, we say tie. If the human beats computer, we say the human. In all other cases, we'll return computer. This is an equivalent way to think about this, so I'd say that we are successful in implementing the beats function. Let's do git status. Okay, git add rps.py, git commit-m, and say implement or add decide winner implementation. Git status, working tree clean, nothing to commit. What's the next step? I think we've done it. Okay, so step 10 says run all the tests, because at this point we should have implemented all of the functions that have tests associated with them. So if we just run test RPS with no arguments right here, that's equivalent to running every single test inside of the test RPS function, inside of the test RPS file. And sure enough, give ourselves a little check mark. We have been successful with implementing all of these functions inside of our code so far. So we've implemented beats, we've implemented deciding a winner, standardizing an RPS choice, and getting a computer choice. Notice the only thing that really remains is getting a human choice and writing the main function. So think of this is that we have all of the ingredients necessary for implementing our game of rock, paper, scissors at the end. So let's see what the next couple steps are. Okay, so getting the human choice. There's no automated tests for this one, since the function does require pausing the program execution using input and waiting for the person to interact. I've got a footnote right here if you want to read about mock testing, but that is way beyond what we want to cover in a class like this. Okay, so implement get human choice, which takes no arguments, but returns exactly rock, exactly paper, or scissors, based on the standardized RPS function that we defined earlier. Okay, so I will pretty much follow this pattern because I want to immediately call the get human choice. So I will add a function right here, get human choice. Okay, and the way that this works is that we want, we probably want some kind of infinite loop, some kind of specific infinite loop, and keep trying until standardize is valid. Okay, try to think, what is that construct inside of Python that allows us to have a dedicated infinite loop, and how do we get this idea of maybe quitting out of that loop or breaking out of that loop once we reach something that's valid? Okay, so right now, if we just run rps.py, we shouldn't see anything happen because we're just running this print get human choice and nothing is happening just yet. Okay, so maybe there's like one thing we can do ahead of time, which is like, okay, so get a human choice using input. We said something about like an infinite loop, and then break out or break out of the loop if the human choice is valid. Okay, so how do we just get the human input? Well, let's say that like human choice is just going to be equal to input. And okay, what is this going to do? Okay, well, running rps.py, notice that, okay, it pauses the execution. I can type some stuff inside of here, and that is going to be bound to the variable human choice. Okay, so what is the prompt going to look like? I'm just going to copy this example, rock, paper, scissors, then space, then these 2 greater than signs. I'm just going to drop this inside of the input statement, which means that this should now be shown to the user. Okay, so if I rerun python rps.py, sure enough, it's going to prompt me to enter something like rock, but nothing happens. Okay, so what is our next step? Well, we haven't done any logic that handles when something is valid versus when it's not valid. And we haven't even dealt with the situation where I could implement, or I could type in all caps rock versus lowercase rock versus canon. So here's an idea. Well, how do we maybe get out of this if it is a valid choice? Well, we could use that standardized RPS choice from a second ago. So maybe say what happens, or maybe what happens if we call standardized RPS choice on the human choice. So something should get printed out because now we are returning something. And I hope to show something along the lines of it will show me some feedback as to whether or not this is close to what this function should be valid with. So if I do all caps rock, it does rock. But if I do just canon, okay, so here's a bug. Like in the case where I did canon, I wanted to loop and say something like try again. Okay, so there's a little bit of a bug still in this case where the human can do something invalid. But we have all the ingredients here. We can standardize the RPS choice and we can solicit an input from the human. So the only things that are missing is this infinite while loop and some idea of like breaking out and that print statement that I mentioned earlier that says something like unknown option try again. Okay, so this is where we would want some kind of infinite loop, so maybe like while true. And inside that infinite loop, we're going to ask for the user to make a choice. Oh, but now we have an option. So if it is valid, we want to return it. If it's not valid, we want to say something like try again and jump back up to the top of the while loop. Okay, so now let's put our standardized RPS choice inside of an if statement. So if it is valid, then we will just return it. Oh, well, wait a minute. Maybe I do need to still assign this to a variable because what do I return here otherwise? Okay, so let's say standardized is equal to the result of calling standardized RPS choice. And we can say if this is something, so if this is basically not an empty string, so if standardized, then we'll just return standardized. Otherwise, otherwise we want to print something like, what do we want to print? Unknown option, print unknown. Okay, well, what is the standardized thing? Well, that's the human choice. So let's convert this to an F string and replace the word canon with the human choice, the raw choice, and try again. Okay, so let's tidy up the code and kind of reason through this one more time. Okay, so step one is that we're going to solicit the human input. Then we're going to standardize it. In the event that it's okay, we'll just return it. Otherwise, we'll print unknown and jump back up to the while loop to ask the human to try again. Let's try it out. Yeah, the canon isn't valid. Paper's valid when we return it. Let's try that again. All caps paper. All caps rock. I think we have it. Let's do one more time. Scissors. I think we have it. Okay, so notice that we did manual testing on a couple different occasions so that we could try to see whether or not our code is meeting expectations. Okay, so therefore, we are done with this get human choice, and I think we're pretty much ready to take all of our pieces, put them together inside of this final implementation of rps.py. Yep, so tidy up our code, remove any debug statements, and let's make a commit. Okay, what did we just implement? We just implemented the get computer choice. So let's do get status, get add rps.py, get commit-m, implement get human underscore choice. Cool, get status, head by 5. Okay, put the pieces together in the main. Here we go. So we're ready to use all the pieces we've defined so far to complete our rock, paper, scissors implementation. So we need to first get the computer choice, get a human choice, and decide winner. I think we pretty much have this. Okay, so main. Let's maybe zoom out and get a high-level idea of everything that we've done so far. So let's see, we can get a computer choice, we can probably don't even need to do this standardized choice. We probably don't need to worry about this beats function, because notice that these three, so getting the computer choice, getting the human choice, and deciding the winner, is really all that the human's ever going to need to see. Okay, so in the main, let's write ourselves a little bit of some notes before we start. So we need to decide the winner, we need to get a human choice, so we're going to need that thing, and we're going to need to get a computer choice somewhere. Okay, so in rock, paper, scissors, the first thing that we want to do is we probably want to get a human choice, then we want to get a computer choice, and then dependent on that, we want to print some information about deciding the winner. So let's say that our first step is that we just say that the human is just the result of getting the human choice. Well, what's that do? Well, if we print out human, then we probably should just see, try again, Python 3, rps.py, scroll down so we can get some feedback immediately. And notice we are writing inside of the main, and our very last block at the end is simply calling this main function that we define right here. So running rps.py should just run the get human choice and bind it to a variable called human, and then just print that out once we interact with it. So this was a second ago where I was like, rock. Nope, that's not right. Canon isn't right. How about paper? Paper is valid, so we printed out paper right here. Part 1 is done. Next, computer. Computer is going to be equal to getting the computer choice. So let's add that right there. Add an open close parenthesis in order to call that function. Maybe we'll print out both human and computer now. So let's say we run Python 3 rps.py. We're prompted for an input. I'm going to choose paper. Ooh, okay, so it would have been a tie, but we just printed that because we didn't decide the winner yet. Let's try that again. Okay, so paper, paper, scissors, paper, paper, scissors, rock, rock, scissors. Awesome. Okay, so very last step. Let's print what happens when we decide the winner. Decide winner. We'll wrap all this in parentheses. Decide winner, we said, takes a human followed by a computer. We have a human followed by a computer. So let's see what happens when we run this. Rock. It was a tie. Paper. Okay, so let's kind of jump back up to what did we actually want to accomplish. Well, right now we have part of this. So the human can choose something, which looks good, but we also want some feedback about what the computer chose and who the winner was. Okay, so let's put these last couple pieces together. So how do we know what the computer chose? I'd really appreciate some feedback about that before it just tells us what the answer was. So let's add a print statement inside of here to tell us what the computer chose. I will convert this to an f string, get the variable for what the computer chose, and paste that inside of here, so it will now show what was actually chosen by the computer. Let's run this again and see if this feels a little bit better. So I'm going to choose paper. Okay, we are very close. So computer chose paper. This right here, we want to show something about an indication that this was the winner. Okay, so very last step, let's just print out the winner. So in addition to just deciding the winner, let's maybe just cast that to, or assign that to a variable. So put in the human and the computer. We don't need this print statement anymore, but instead we will just print out, so f string, paste that in there. Who is the winner? Well, the winner is inside of this variable. So now the sum total of everything we've written so far is that we will print out the computer choice, decide the winner, and then actually print the information out. Final check. Choose one of these. Paper. Let's look at these side by side. We ran rps.py. We chose a choice. It gave us some feedback as to what the computer chose, and it decided the overall winner. Once we were done, it returned us to our shell prompt in order to run the game one more time. I think we have all of this. Let's do a couple last things to tidy up and maybe review what we've seen so far. So we don't need this pass statement down here. I kind of like grouping my print statements together. So personal preference, the exact way you write these is going to be really kind of dependent on what you like. Maybe I'll do a little bit of tidying up right here. Like I prefer about 2 spaces between each of my functions. Again, a little bit of personal preference with that. But with that, I think we have a successful game. Let's test it one more time manually. Rock. Let's maybe run test RPS one more time just to confirm all of our tests are still passing. Git status, and let's make our final commit. Git add rps.py, git status, red to green, git commit -m, finish RPS implementation. Awesome. Git status one more time to confirm. Okay, we have not pushed so far. So far, if we look back at the repository out on GitHub, if we refresh the page, you'll see that none of the code that I've written is out here just yet. The very last step is that we need to make a push to send our code from our local machine up to GitHub. 3, 2, 1, push, successful. Main was updated on github.iu.edu. Let me refresh this again. Notice that it's about to pick up whether or not this thing is successful. Maybe I'll refresh one more time because it's usually pretty quick. And sure enough, all of our tests passed successfully on GitHub as well. Okay, so folks, yep, we did step 13, checking that the code on GitHub met expectations. Okay, let's say how many commits were on GitHub. Are there 7, 1 for the initial commit, and 6 more that we made along the way? Do all the tests pass? Well, let's check these things. So are there 7 commits? Do all the tests pass? Okay, we do have the 7 commits for each of those steps as we accomplish them. And we have the little green check mark indicating that everything looks okay on GitHub as well. Awesome. So give ourselves a little check mark next to 13. Very last step, tag a new version. Okay, so we've created an implementation that has all of the core behaviors for rock, paper, scissors. So let's call this version 0.1. Version 0.1 indicating that we're starting the implementation, and we're pretty confident that this is a good working implementation. Okay, so push the changes to GitHub. We did that already. Tagging. Tagging might take a little bit, and pushing the tag to GitHub. So this is very much one. I don't really expect you to memorize this one. So what are the steps? Well, we did already push. Maybe we can do that one more time just to confirm. We will tag the main branch for 0.1, tag-a v1.0.0, initial RPS release with implementation and unit tests. That sounds good. I'm going to copy that, Control-Shift-V to paste inside. That created the tag. Very last step, push the tag to GitHub. Copy. I'm going to paste this in. I'm not going to run just yet though, just so I can show you before and after. There's nothing on GitHub that says anything about version like 0.1.0 right here, but I expect as soon as I run this, I should be able to refresh the page and see that there's an additional release. So, moment of truth, push it up to GitHub. We get the confirmation that a new tag, version 1.0.0, version 0.1.0 was created. If I refresh the page on GitHub, now there is indeed a tag showing that we did create our tag on GitHub. Okay, so submit to Canvas, very last step. Everybody, folks, hope this has been useful. As usual, send me a message on Discord or anything else with any questions, and hope to see you around.